copy and paste up the graph in a minute anyway. So lads, what do we get for the first one? 1. Next part after that, you're going up in gaps of 0.5, aren't you? So you're doing table function, and you're doing 2 to the power of x. But this time you're going up in 0.5s. Start at 0, and then go as far as 3. Step at 0.5. You should get full marks every time, lads. So see those points there? 1, 1.4, 2, 2.8, 3. Let's call it. So what's that? 1.41. This one here. 2. That's going to be 4, and that's going to be 6. That's going to be 2.83, oddly enough. And this one here, 2.5. 5.66, yeah. Thank you. Now, I got to do the g of x function, which I'll do separately. Oh, sorry, 8, you're right. Thanks. It's an exponential function, so. Alright, next one is put in your numbers here. (9x). John, what you got for this one?
-1.
And what numbers did you get?
-1.
Yeah, go for it.
2.75.
-1, 2.75, yeah.
5.
Yeah.
5.75.
Yeah.
5.
Yeah.
2.75.
Yeah.
-1.
John, quick question. Is that guaranteed to be the maximum of that function?
Yes.
Why is it guaranteed to be the maximum? Yeah. Perfect. Peter? You can put 2 functions in at one time if you want, but I only ever do one. So just press equals to bypass by the gx. Alright. Now, if I remember correctly, I think I have a marking scheme for this. I'll just copy and paste the graph, okay? It might be a bit quicker than me drawing it. Is that it there?
Yeah.
It's not great though, is it? Ah, you'll live. So did anybody get a graph like that?
Yeah.
Yeah, I think I'll draw it. It's just not a great one. Much better here. Alright, call me out the first points of this one. The curve, the 2 to the power of x one, what are the points? So we call me out the points. Sorry?
0, 1.
0, 1, yeah.
0.5.
So 0.5 and 1.4? Yeah. 1 and?
2.
Yeah. 1.5 and? 2 and? 2.5 and? Yeah, it's a bit high. Yeah. And the last one's 3 and 8, was it? Alright. So we have it there. That was easy. Now, that's an exponential function, which means that it's getting steeper as we go on. I lost a mark or 2 there. Where did I lose my marks? Probably there. I don't really go through it, do I? So if you're in your leaving cert, do it in pencil. Go again. Pencil for these ones, yeah? The Christmas same deal. Pencil's the way to go. Now what about the next one? The curve. 0 what? 0 minus 1, yeah. 0.5, 2.75, yeah. 1, 5, yeah.
5.
Yeah.
2, 5.
Yeah.
2.5.
Yeah. Alright. So we got our red curve here. Okay, now what's the next thing it wants from us? Alright. It wants us to solve this here. Now what is this? Alright. Yeah, it looks a lot like what we had here, doesn't it?
Yeah.
So what happens if I move this over the other side? What happens if I move these parts over the other side? What happens? I get 2 to the power of x equals 9x minus 3x squared minus 1. What do you know about that equation? No, that equation is the same as which line? That's the same as this line here, isn't it? Sorry, I'll do with better colours, stick colours and mixing there. Alright, this blue equation is actually the same equation you guys used to get this here. And the green equation is what? The same as? The green line is the same as this equation. You see the way both equations were in there? So this means when one line equals the other line. So what points does that happen at? Or what x values does it happen at? What do you reckon? 0.3, because that's 0.5. 5 blocks to get to 0.5. So 3 blocks would be around 0.3, wouldn't it? Yeah. And what's the other value then? The other value is down here. That's where the both graphs hit each other. What do you reckon? 2.25 or something like that? Close to 2.3, but not quite. So 2.25. That'll do me. Okay, well that was very tricky. I expected probably none of you to get that out. Did anybody get it anyway? Yeah, that was very tricky. Like the further back we go, the more difficult it gets as well. Most of the marks go for the graph, though. Just draw the graph. Good. Alright, let k be the number such that 2 to the power k equals 6. Which graph had 2 to the power of x again? Which one was it? Which colour? Which one? The yellow and green one. 2 to the power of x equals 6. The y value equals 6. So where does the y value equal 6? Over here, drop it. And what do we get? 2.6. That's when 2 to the power of x equals 6. So this means your x value is 2.6. So your k value must have been 2.6. And x equals 2.6. This means k equals 2.6. If you aren't sure, put it into the calculator and put in 2 to the power of 2.6. What should it be our rough answer when we put this in? Should be roughly 6. Close enough, isn't it?
Sure. How did you get 2.6?
So see the way it's 2 to the power k, and it says, see the way it says use your graph. I was going, okay, which graph did I do 2 to the power of anything? And then I go, oh, that must mean it's the green line, because that's where it drew 2 to the power of x. And then it goes, it wants the output to be 6. So at this point here is where the y value is 6, and 2 to the power of x. Then 6 is 2 to the power of x. You go, oh, what x value caused that to happen? And then I went down, the x value that caused that to happen was 2.6. So I realized k was 2.6. Once again, I think most people would find that very difficult. This, however, you're going to find really easy. All right. Using your graph, what can you see here? 0, 0, 1 what? What? 5, 2, 3, 4. Yeah. Now this is symmetrical, which means 9 is the undisputed max. Which means it's the same on both sides, right? You see that a lot. Next thing, that goes for a lot of marks straight away, so don't worry about that. Now, what does it want from us? Trapezoidal rule. I'll just do the trapezoidal rule here, if that's okay. So what is the trapezoidal rule from your tables? Everybody has maths tables? Because you won't be getting them, so who doesn't have maths tables?
Oh, pretty sure I do.
Well, will you have them for your Christmas test? How many people know the trapezoidal rule off by heart without using the tables? Go on, go for it.
The first and last.
Yeah, that's not the full thing, but grand first plus last, yeah.
Yeah.
2 times what?
Uh,
Remaining. Okay, but what's on the outside? What does H stand for? No. We gave out this at the time. Doesn't mean the height.
Oh, the width.
It means the width. Okay. Where can you find that in your tables? Matthew, do you know where you can find that? Is it area approximation on the contents? I think it's around. Danny, just go left one. Back a page, Danny. Forward a page, I mean. Yeah, there it is. What page is that, Danny? 12. On page 12, on your notes, if you want to write down H over 2, first plus last, 2 times remainder, you're more than welcome. You can do that now if you want. Alright? But that's translating what it says underneath into what something that you'd actually know how to use. Okay? Now what's the first one? The first height? 0. 0, see? No height.
Not like a distance between them.
0, no, sorry, H is 1. As in the distance between consecutive points is 1. But the first height is 0. The width is 1, but the first height is 0. What's the last height?
0.
0 as well. 2 times the remainder. 5 plus 8 plus 9 plus 8 plus 5. Okay. And we get is 26. I think it's 35. 2 times 35 is 70. A half is 70. Anybody?
35.
Did anybody get that? Yeah. Handy. It's easy, isn't it? You'd be delighted that came up. The only thing where it might catch you out is if I gave you this curve instead, like this. What's the initial height? Tip. You get what I'm saying? Or if I gave you this curve instead, where I let's say I stop it here. What's the last height? 2 as well. And it'll be going straight down then, yeah? So that can happen. Now, done. This one. Now this is extremely difficult. I don't know why it's here, to be honest. I think it could have been a misprint by study clicks to get it in the ordinary papers, but I'm just going to show you a graph of something really quickly. I'm going to show you. Huh? Oh yeah, go on. The graph of a cubic function f is shown, so this means it's y equals x cubed, something x cubed. It could be plus something x plus a regular number at the end. Do you get what I'm saying? Could be some sort of cubic equation. I am pretty sure what it looks like, right? And what I'm trying to figure out is when I differentiate it. So when I differentiate it, if this was 3x cubed, yeah, what would I get? I'd get 6x, which would be U-shaped. Here, are you looking? If this was a 3x squared, I'd get, my derivative would be 6x squared, which is U-shaped. However, if that was minus 3x squared, what would I get then? Negative 6x squared, which would be N-shaped. So I don't know whether to choose between a U-shape or an N-shape at the moment. That's my problem, okay? The next thing is, you can see they're giving me all these choices. Okay? Now, they're trying to give me all these choices of, does it have roots, does it not have roots? Okay? Now, here's the deal. I think I've just figured out what it is. For cubic functions, what usually happens? I figured it out now. We usually have an up or a down, or we have a, what's the other one? A down followed by an up. But what happens? There's usually a maximum and a minimum. Does that make sense? Would you agree? We usually get a max and a min. Does that make sense? Now, here's actually the trick to this. Usually when there's a max and minimum, the derivative would be, let's say, N-shaped or U-shaped. It doesn't matter which one it is. But what would happen is, where your derivative crosses the axis, so let's say for argument's sake, the x value was, the maximum is 224, and the minimum was 3 minus 22. Would everybody be happy with that being the max and the minimum of that graph I just made up? Now, what would happen is, if I graph the derivative of it, it will cross the axis at 2 and 3. You get what I'm saying? The x values of your max and min, if you graph out the derivative of the function, they will also cross here and here as well. All right, let me do this one more time. So, does this cubic function have a max and a min? Does it go up, down, and back up again? I think this one's always on its way up. So, because it hasn't got a max or a min, it doesn't cross the x axis. Does that make sense? Sorry, the derivative doesn't cross the x axis. So which one is that? It can either be B or C. Now, there lies my problem. I don't know if it's B or C. So what I'd do in my calculator is I'd start messing around a little bit. And what I'd start doing is I'd start drawing a function or two out. I'd draw y equals x cubed to begin. What do we know about y equals x cubed? It's always increasing. What do we know about y equals minus x cubed? Always decreasing. So I think I've answered my question here, haven't I? The original graph is always increasing. This means its derivative has to be positive. And if its derivative is positive, it's U-shaped. Therefore, I eliminated it down to B. Alright. To hit this point home, just in case you guys really don't get what we're doing here, right? Here's what we're going to do. I'm going to make up an equation here. It's going to be a really easy equation. Yeah, go on. Alright. Alright, here's what I want you to do. Alright. I'm sorry. Right. I've just made up a question on the top of my head here. Because I am that good. Alright. Here's what I want us to do. Really quickly, I want us to draw this graph here in your calculator. So I want you to draw it, a rough diagram of it. Next thing I want you to do is you differentiate it. What happens when you differentiate it? What does it turn into? Minus, plus 3. What I want you to do is I want you to draw the derivative and the original function on the same graph right now. Okay. Now, Darren, do you call out the equation I just gave you? Oh, never mind. X cubed minus 5x squared, is it? What came after that? Plus 3x? And what was at the end? Minus 7. Alright, the minus 7 sort of mucked things up a bit, but you'll see what I mean now. So, if I zoom downwards, does everybody see your max and your min? Max is there and min is there, right? Now, here's what I want us to zoom in on. Alright? What I want us to zoom in on is the fact that the fact that the max and the min cross the axis. See where the max and the min cross the axis? Oh, sorry. See where the max and min occur. Would everybody agree the min occurs at an x value of 3? And the max occurs somewhere in between 0 and 1. 0 and 1. Now, the next thing I'm going to do is I'm going to draw the derivative. And the derivative is, what's the derivative? 3x squared minus 3x squared minus 10x plus 3. Here's my prediction. Does anybody see something in common with the derivative and the cubic? Not same slope, but something else. Alright, look at this. Where the maximum occurs of the cubic, what happens to the derivative? Where the maximum occurs of the cubic, the derivative crosses the axis at the same point. Do you remember what we said? At the maximum point, the derivative has to be equal to 0 because the slope is equal to 0. The slope value is 0 because the derivative is equal to 0. Okay? What do we know about the minimum? And what's directly above it? So, only thing I want you guys to take home from this is this. If there's a maximum and a minimum, yeah, and you draw a graph of the derivative will cross the axis in the same x positions where your maximum and minimum occurred. Does that make sense? Alright? So even if I had an x squared graph, the line would cross the axis once where the maximum occurs. Okay? So that's alright. So can somebody repeat that one more time? If there's a maximum and minimum of a curve, what happens when you graph the derivative? The x values where it crosses the x-axis will be the same as the x values of the maximum minimum of the original function. Because I realized that this graph here had no maximum and minimum, I knew it couldn't cross the line. It couldn't cross the axis, because otherwise it would have two values, correct? It can't have a maximum and minimum because they don't exist. So therefore I knew is either B or C. I didn't know whether it was a plus x cubed or a minus x cubed. I quickly drew two sketches of both of them to figure out which one's always going down and which one's always going up. And that's how I figured out that the answer was C, not B. All right, and we're done. I think we need